Hi, hello everyone. My name is Yao Yao, and this presentation is for Data 625, 1980 Data Visualization. And this is specifically for Unit 6 assignment, Network Graphics. So basically, we're going to look at two data sets. Hello everyone, my name is Yao Yao, and this presentation is prepared for Data 625 9080 Data Visualization. And more specifically, this is for Unit 6 assignment, Network Graphics. We're going to look at two data sets and talk about the findings. Let's first look at the Network 2 dataset. This dataset represents a moderately robust network of nodes with connections and betweenness centrality indicating each node's importance in maintaining communication flow. For example, nodes like cipher and stealth, right? And cipher, the ones you can see in the graphics, have high centrality, acting like key hubs. They are showing in the color of red. And the more connections, the more betweenness, the deeper the color red. Making the network vulnerable if they are compromised by malware or technical failure. In contrast, less central nodes like Phantom. Let's look at Phantom, for example. They are really just pose a minimal risk if it's taken offline. So this network would struggle to reroute messages if critical nodes fails, suggesting limited redundancy. If we were to improve resilience, I recommend adding alternative paths between major nodes and distributing network loads more evenly to reduce reliance of a few critical points. Okay, now let's look at Network 3 datasets. And this dataset represents a moderately complex network with 50 unique nodes and 49 distinct connections. The network structure suggests a moderately robust configuration with key nodes like Nebula and Starhawk exhibiting high betweenness centrality. Again, the higher the centrality is, the dark the color is in red for the nodes. And these nodes serve as critical connectors for communication flow. If one of these nodes were compromised, the network's functionality could be significantly impaired. And in contrast, nodes like Astra, Orion, or Zenquan have no centrality value, indicating minimal impact on overall performance if compromised. Despite some resilience from distributed connections, the network remains vulnerable to single point of failure. So I recommend enhancing redundancy by creating alternative paths around central nodes and monitoring high centrality nodes closely to mitigate risks. So I based my assessment on the network's structure, specifically analyzing node connectivity and betweenness centrality, which measures how often a node appears on the shortest path between others. For example, in data 3, nodes like Nebula and Starhawk show the highest centrality, meaning that they act as major communication hubs. If one of these nodes were compromised, it will likely disrupt the multiple routes. And there are also, on the contrary, nodes with zero centrality. They have minimal influence on data flow, so their failure would have little impact. And the near one-to-one ratio of nodes to connections also suggests limited redundancy, making the network more fragile than robust. These insights led me to recommend adding backup routes and closely monitoring critical nodes to improve resilience. And thank you. That is all for today's